Good afternoon. It's a huge honor and pleasure to be back in Kerala presenting at this pretty momentous opportunity in terms of kicking off this GenAI revolution in Kerala. So today, you heard a lot about generative AI in the software, in machine learning, use it in the Watson setting, but what I'm going to talk to you about today is generative AI for hardware systems, generative AI for embodied systems. And it is extremely important to think about how we're going to use generative AI, not just in applications like social media networking or recommendations, but really try to use them in a way that we can change the state of the world. So my role here is, my first role is as the Director of AI at the Alan Turing Institute, and I direct the AI program, which is the National Institute for AI and Data Science in the UK. But I'm also a chair professor at the University of Edinburgh. And one of the things that I've been focusing on is looking at the application of robotics in different walks of our life. So for example, if we think about where is robotics playing a big part, there are traditional areas like manufacturing, there are traditional areas like the nuclear industry, but there are also new areas in healthcare, in the care for the aged, as well as smart cities, where robotics is playing an increasingly important role. So when we talk about robotics, the robotics of yesterday was all about teleoperations. So getting a robot to mimic what you've taught it to do. The research is moving from that to increasing autonomy in systems. In other words, you're trying to get robots that can make decisions on its own, start making informed decisions that are potentially beyond the realms of human intelligence. But in the next 5 to 10 years, what we're going to see is not solutions that are fully autonomous. What we're going to see are solutions that are somewhere in between, where we have humans still in control of many of the high-level volition, the high-level goals, but the robots taking a lot of decisions on their own. And this is what we call shared autonomy. And why? Why do we care about shared autonomy? Why should we think about using robotics in this form in various challenges? So here I've listed a few challenges that our lab works on in Edinburgh. And across these different domains, we have used AI and data-driven machine learning to address some of the grand challenges. So grand challenges including things like dealing with the industrial demands of food security, healthcare, asset inspection. So when you have got aging infrastructure like buildings, bridges, how do we deal with that? Flexible redeployment in settings like the pandemic that we have seen. And in all of these settings, if we wait for AI systems or machine learning systems to give you a perfect solution, we've got to wait for a bit. So instead, this concept of working collaboratively between humans and AI systems, whether it's embodied or whether it is in the software, that is the right approach to take. So let me give you a few examples of where we have deployed such systems. And this is particularly poignant in settings or grand challenges in India. So for example, India is very ambitious in building nuclear power plants for energy security, and down the line, we will hit a problem where decommissioning of such nuclear power plants will become a challenge. It will be an expensive challenge. It will have issues where humans would have to put themselves in their own danger. So the idea is, using robotic systems like what you see here, we have solutions that would take the problems that typically would have been handled either by teleoperation or by manual intervention and take that to a level where shared autonomy can play a significant role and really take people out of harm's way. Such robots can also be used in extreme environments. So Kerala is very, very central to some of the sort of food security and energy security solutions. And we have seen in Cochin shipyard, we've got, I think today or tomorrow, there is a new big port being sort of opened in Trivandrum. And really, some of the big challenges of operating such a big plant, whether it's on the shores or whether it's offshore, is actually pretty daunting. And robotics can, again, play a big solution in trying to solve some of those problems. So, for example, if you have quadruped robotic systems that can do asset inspection on the surface, which are pretty dangerous in different environmental and conditions that can be pretty hostile, then we can get robotic platforms or systems that can solve, and you can basically operate these from the comfort of your home. Similarly, when assets need to be inspected, then we can have robotic solutions that are able to deploy these assets in a semi-controlled fashion, in a semi-autonomous fashion. So these are just little glimpses of projects where traditional automation has been transformed by the use of AI and generative AI into smarter machines, smarter automation. So portfolios include what we've seen in terms of nuclear decommissioning, collaborative manufacturing, remote operations, as well as sort of disaster recovery. Your next speaker is going to be somebody who's done a spacewalk on the space station. We have an interesting project in collaboration with NASA on their journey to Mars. So if you think about the space station is a pretty hostile environment. So every time something goes wrong, an astronaut has to put themselves in danger, wear a spacesuit, walk in the presence of space debris. So what if robotics can take people out of their harm's way and solve some of those problems? So we've been working with NASA, the Johnson Space Center, one of the few institutions in Europe, few institutions in the world, I would say, and the only institution in Europe that is working on the NASA Valkyrie robot for pre-deployment missions to Mars. It's about robots that can work in environments built for humans and do operations and maintain assets while the astronaut is busy with other stuff or is on the way back to Earth. So this seems like a pretty exotic application. Space, India is leading in one of the, in deploying space solutions at a fraction of a cost. And literally, those solutions will also be required, robotic solutions will also be required for India's missions. But closer to home, we can use this kind of collaborative assets in things like dyadic collaborative manipulation. So, for example, this is a collaboration with Honda on assembly lines, where you want robots and humans to work together to collaboratively solve a problem of lifting heavy weights. So you want to do the best of both worlds. You want a solution where the robots are doing literally the heavy lifting. It is doing all the precise manipulations, but the volition of how and when these operations happen come from the humans. And this slide is particularly important for where should we look at going forward with AI. I think India has done a great job in terms of jumping the copper wire generation and having overtaken many Western and global competition in the digital space, especially if I look at the kind of mobile-based services that are being delivered here in India. It is impressive. On the AI front, I think it is important that we do not try to just catch up or do things that everybody else is doing, but actually think about making that leap and go for AI solutions that are not just low-value manufacturing settings, but extremely high-value manufacturing or other sort of, not just manufacturing, in general, much more high-value assets. So an example is creating a chain, say, in an aircraft manufacturing setting, where you go from traditional rigs to human-assisted and robotic rigs that work close to each other. The last bit I want to talk a little bit in terms of the exemplars is also in the healthcare domain. So in addition to robots that work in classical settings, the industrial settings, manufacturing settings, we also need robots in solutions for healthcare. So one example is the situation where we are using robots for treatment of neurodegenerative diseases. So for example, Parkinson's, multiple sclerosis, people who've had an injury or congenital sort of problems. So robotics can play a huge role in using or creating systems that can enable efficient and more active aspects related to rehabilitation. So, for example, we worked with the NHS in England to look at solutions where patients who have lost a limb are rehabilitated by using upper limb prostheses that are not just devices that operate based on some sort of pre-programmed setting, but use biointerfaces to create smart activation methods that are easy for people to operate. So, the title of my talk was AI and Robotics and the Future of Work. So the idea or the question is, how is technologies like generative AI, like embodied AI and machine learning in sort of embodied systems, how are they going to change the way we live and work? I'm not sure how many of you recognize this picture. This is, Tony Stark, one of my favorite movies. And this vision of sitting in the comfort of your office and controlling multiple agents, multiple systems, is no longer a science fiction. So I want to give you a very concrete example where we actually deployed some of the machine learning and robotics technologies in a cafe in Tokyo, in Japan. And what you can see here is the robot, it's called a telebarista. It is actually, you can go in there, order a cup of coffee and chocolates, and it'll do this nice little demonstration of stages that are actually pretty hard for robotics at the moment. So manipulation, sensing, use of different tools, and then fine sensitive control. So it's one of those things that humans take for granted. We walk, manipulate every day, but trying to get a robot to do these fine manipulation tasks are pretty hard. So this is pretty impressive in itself, but that is not the main message of this video. The main message of this video is that this is being operated in a shared autonomy mode. The robot is doing a lot of the operations on its own, but the intermediate stages and the interaction with the customer is being done by people who are sitting in different cities in Japan, in Osaka, in Tokyo, in Nara. And these are people who are either paraplegics or have a stroke, and they cannot normally be in the workforce. So this is an example of AI for social good, where people who would normally not be in the workforce would be able to come back into the workforce using robotics technologies. So we do not want to push robotics or AI technologies down the throat of some place where it's not needed, but we do want to create scenarios where this can be used in an effective fashion to really change the way we live and work. So, just trying to sort of wrap this up, there are still lots of open underlying scientific challenges. I've listed a few here that our lab and our university in informatics works on. So I'm not going to go into much details of this. Things like using both software and hardware to ensure safety and security is paramount. And this is true for hardware systems or software systems. Today morning you had the ministers emphasizing that there is two sides of the coin. We have to make sure that we use AI for social good. There is the challenge of reducing the sim-to-real gap. Robots are typically fragile, so how do we make sure that these things don't break? So the way to do that is by creating effective simulation environments where we can. It's a playground for testing this. And finally, verifiable and explainable methods, things that can be tested against safety and vulnerability. So as scientists, as people who develop this technology, our responsibility is not just to say, this is a wonderful piece of technology. It's trying to get the public to understand where it works and where it does not. What are the vulnerabilities where it would fail? Because that is equally important to finding solutions. Things that I haven't touched upon today are things like shared autonomy, sort of key questions in shared autonomy like moral and ethical decisions. How do we make sure the security of our systems are solved? How do we make sure the transfer of control is safe? And how do we make sure the learning systems do not disrupt the things that we plan for? So at the Alan Turing Institute, we address some of those big challenges in shared autonomy. So I want to come to the conclusion of this talk by quoting one of my favorite authors, Arthur C. Clarke. And this little quote is actually quite poignant. We tend to overestimate technology in the short term. What it means is that people go with the hype and they think that generative AI or robotics or AI or machine learning in general is the next best thing to slice bread and it can solve all your problems. And that can be damaging if you don't take it with a pinch of salt and understand both the benefits and the problems with the existing technology. On the other hand, the second part of the statement is we tend to underestimate the technology in the long term. In other words, if we are not doing what we are doing now, if Kerala and India is not preparing for the technologies that are going to come and affect the world in 5 years' time, 10 years' time, we will be left behind. So I think we have to find that right balance between not overestimating the technology now, understanding the limitations, but also preparing ourselves for the future. So what I'm going to do is to show you a quick video that summarizes the research that we do in our group at Edinburgh at Informatics, and then sort of come to another big part of this presentation, which is a collaboration that we are announcing today. So the video here next. Welcome to the Statistical Machine Learning and Motor Control group at the University of Edinburgh. Here we do exciting world-leading research on robotics, machine learning, and data-driven techniques using artificial intelligence to make robots a lot more versatile and adaptive to the real-world situations. We do work across domains, so applying the core problems in robotics and machine learning to domains in oil and gas, transport, healthcare, as well as things like the challenges of exploration in outer space.
My research is focused on designing exoskeleton controllers that can assist people completing tasks such as walking. And to achieve this, what we do is we build quite complex neuromuscular models of human subjects and combine this with a very detailed set of motion data that we can collect in our gate lab.
We hope that with this setup and combining robotic assistance with electrical stimulation, physical therapists can have a tool to personalize the intervention and improve the outcomes of physical therapy.
My research is about robot localization in changing environments. when the robot's view is nearly occluded by large moving objects.
We want the robot to learn which objects are of interest without requiring a human to provide information about the shape or the visual appearance of these objects.
In order to enable robots to move while in contact, for example, when wiping a table or pushing a heavy object, my research focuses on how to plan or how to learn those types of physical contact interactions.
We are developing mathematical models to enable a robot to capture heavy and moving objects with 2 arms. At the same time, we are handling impact.
My research involves both humans and robots, where first we enable robots to predict humans' intentions and actions, and we also generate safe robot actions in order to help the humans reach their goal.
In construction, robots are often operated by humans in dangerous environments, needing expensive training. To reduce the operator burden, I'm working on shared autonomy, which combines human input and autonomous methods so the human can best utilize their expertise.
I'm really interested in human-robot collaboration, so how we can enable robots to perform a common task effectively with human, such as pouring a wine into a human's glass. But humans are really difficult to predict, and so I'm interested in how we can better make those predictions.
I'm working on the development of robots that can be easily taught to manipulate objects and potentially collaborate with people or assist people in need just by giving a demonstration of the task.
I'm working on leg robots to make them traverse challenging terrains. The idea we propose is to start with a capable controller that already works on the robot and try to extend and add capabilities to make the robot cross challenging terrains.
I'm working as a software engineer in a field robotics lab, and also I'm doing some research about quadruped robots. I'm working on how those robots with 4 legs should plan their footsteps considering the torque limits on their legs.
When robots have to perform manipulation and walk simultaneously, they face a lot of uncertainty. One way we can increase the robustness of the system is by taking into account the capabilities of the robot, so its motors and also the contact stability.
There are many conditions that we cannot predict. For instance, when we are navigating in an offshore platform, we might encounter a floor that is wet. A way of dealing with this kind of uncertainties is by replanning quickly new motions.
I'm working on building better robots for specific tasks. So a robot that walks might need to be built a little differently than one that jumps. And so I'm working to create algorithms that modify the designs based on the tasks. And I'm looking at making those more efficient and physically realistic.
My work focuses on motion planning, especially when it comes to the environment changes. There are either obstacles coming in and out, or the objects that the robot is trying to pick up and move are moving. And this is especially useful when working with robots that need to be safe around people and other robots.
The environment may have many different inclined slopes, and this gives rise to a lot of different options of when to play the foot and where to play the foot.
If you've liked some of the research that you've seen in the video and would like to work on some of these exciting platforms and projects, please do get in touch with us, and we'd love to have you as part of our team. So the other big thing that we are here for today, and the connection to the Generative AI conference and the efforts that are being set up here, is this new partnership that we are announcing between the University of Edinburgh, the Digital University of Kerala, in the context of the new Digital Science Park that is being held in Trivandrum. So I'm going to hand over to the MC to get to the next part of this program.
Thank you, Mr. Sethu Vijayakumar. Ladies and gentlemen, as we are gathered today for a significant event, the announcement of a collaborative research agreement between the Digital Science Park Centre for Excellence in AI at the University of Edinburgh in collaboration with the Alan Turing Institute. To begin this momentous occasion, I would like to invite some of our esteemed guests to join us on stage. please join me in welcoming our Honorable Minister P. Rajiv Sir on stage. Along with him, could we have the presence of Professor Saji Gopinath, Vice Chancellor, DUK. Also, we would like to have the presence of Professor Alex James, Dean, DUK. We are also honored to have with us Professor Sethu Vijayakumar, Christian Novotny, and Atulya Arvind from the University of Edinburgh for this announcement. Let's welcome this party for the collaboration with a huge round of applause, please.
He's coming.
This collaboration marks as a new chapter in the advancement of artificial intelligence research and development, leveraging the combined strengths in AI chips, generative AI, and robotics of the Digital Science Park, Center for Excellence in AI, the University of Edinburgh, and the Alan Turing Institute. Once again, reiterating in benefit of everybody, this collaboration marks a new chapter in the advancement of artificial intelligence, research and development, leveraging the combined strengths in AI chips, generative AI, and robotics of the Digital Science Park, Center for Excellence in AI, the University of Edinburgh, and the Alan Turing Institute. Ladies and gentlemen, once again, put your hands together. As we have all the stakeholders on stage, thank you all for being a part of this significant milestone. Let us now proceed with the exchange of the agreement. And ladies and gentlemen, join us as we have Professor Alex and Professor Sethu handing over the agreement to the Honorable Minister and the Vice Chancellor, marking the new collaboration. We are witnessing history in the making. And all cheers to the new collaboration and all the stakeholders involved. Thank you, gentlemen. And we request Mr. Sethu Vijayakumar to please stay back with us as we take this opportunity and thanking him for his presence, time, and all the wonderful insights shared, with a small token, a plaque ceremony to be presented. And let's honor him with a huge round of applause.